Hi, my name is Nora McCabe, and this is how to do a hypothesis test for the difference between two means. Statistical hypothesis test for the difference between two means, and you can find it using the following methods. Here are the different ways to solve. Mean difference measures the absolute difference between the mean value in two different groups. T-test compares the mean of two groups to determine if there is a significant difference. Two-sample t-test tests whether the mean of two samples are equal or different. Formula. The test involves comparing sample means, standard deviations, and sample sizes. Now for my two examples. Here's the first question. Let's read it together. A test was constructed on two different classes to see if there was any significant difference between the performance of two teachers. The final exam scores of 15 students were sampled in the first class, yielding a mean score of 82 with a standard deviation of 2.4. The mean final exam score of the second class was 84 with a standard deviation of 1.7, using a sample of 12 students. Determine if there is any major difference at a 5% significance level. So what we have here is two separate independent groups. The first group of students does not depend on the grades of the second group of students. Now what we need to do is write down the information that we have. So for the first class, the sample size N1 is 15. We're going to write first N1 equals 15. Sorry, I'll make that straight. Because that's 15 students. The sample mean, so we write X, which makes equals. First class is a final exam score of 82. And the sample standard deviation, 2.4. Now we're going to write down for the second class. Second. Here we can see it says 12 students. So N2 equals 12. The sample mean for the second class equals 84, and the standard deviation for the second one equals 1.7. Now we want to determine if there's any major significance at a 5% significance level. So our alpha value is 5%, which converts to 0.05. Now we want to test to see if there's a significant difference between the performance of two teachers. So what's being tested is the alternative hypothesis. So those conducting tests believe that the mean performance or the mean scores generated by the class of these teachers are not the same. So we write that like this. M1 is not the same. M2. For the null hypothesis, they are the same. That is the status quo. So we're going to write M1, mu1 equals M2. So we could say that mu1 minus mu2 is 0. So we're going to write that here. Mu1 minus mu2 equals 0. And for the alternative hypothesis, we're going to write mu1 minus mu2 is not equal 0. I'm going to write it right here. Mu1 minus mu2 equals 0 over here. Hypothesis. So we're going to keep that up there for later because that'll be helpful in a little bit. Now the next thing we need to determine is what type of distribution should we use. Should we use a t-distribution or a normal distribution? If the sample size is large, we want to use a normal distribution. But if the sample size is small, we want to use a t-distribution. And 30 is the number by which we can determine which one we want to use. Since the sample sizes are less than 30, we want to use the t-distribution. So we're just going to write here N 30. Here's the sample size of 15, and there's 12. So the sample sizes are small. So now we know which distribution we want to use. Our next step is to calculate, or rather find, the critical t-values. So alpha is 0.05, which means alpha over 2 is 0.025. So we're going to write that here. Over 2 equals 0.025. Our next step is to calculate the degrees of freedom. We have a nice big formula for that. So we're going to start writing it here. df equals 1 squared over 1 plus s2 squared over n. Put brackets around those. Squared over s1 squared over n1. Put that in parentheses again. Square that. And that's going to be over n1 minus 1 plus s2 squared over n2 divided by, we'll put parentheses around that. That's also going to be squared. And that goes over n2 minus 1 as well. So we're going to do this one step at a time to avoid any mistakes. But for now, we're just going to plug in the numbers. So what I've done here is I've just rewritten it without saying what goes there, so we can just plug that back in with the numbers. S1 is 2.4, and 1 is 15, S2, 1.7, squared, sorry, forgot to put those earlier, 12, 2.4, 15, and then n1 minus 1 is going to come out to 14, so we're just going to write it right away as 14. And then 1.7 squared, and then we're going to have 2. And then again, n2 minus 1 comes out to be 11. And then we're going to plug this all into our calculator and put the numerical value right here. So give me 1 second to calculate this. You get the value of 0.390,417. And then for the bottom, we're going to do these individually and then add them after. You should get 0.0105326 plus, I'm just going to write it down here so we don't run out of room over here, 0.005272279. And then we're going to add this and divide it by this to get the number of 24.7. But if you want to round to the nearest whole number, you're going to get 25. And I'm just going to flip to a clean page because we don't have enough room. It's going to have 25 degrees of freedom, so we're going to do T25, 0.025. And we're going to keep the value that we just solved for right here. Remember, we rounded it to 25, so that's what I'll be putting at the top right there. Now going down to 25 degrees of freedom, we can see that our critical t value is 2.0595. So we're going to write that here. 2.0595. So now we're going to draw a picture. So what we need to do is get our calculated t value and compare it to the critical t value. We want to see if our calculated t value lies in the rejection region or in the middle. So this is our rejection region right here that I'm shading in right now. So we're going to write 2. And then it's also on this side, so we're also going to fill that in. And that's negative, and then this is going to be the positive version. So 2.0595. So it's going to be x bar 1 minus x bar 2. And then the difference between the two means 1, 2, divided by the square root of s1 squared over n1 plus s2 squared over n2. So this is the standard error or standard deviation. So x bar 1 is 82 minus 84, so we're going to write that now. And now we're just plugging in. 82 minus 84. Sorry, it ran out of storage on my phone and it didn't show me until I completed this problem, so I'm just going to walk you through the last few steps. So we have 82 minus 84 minus 0, so that goes in parentheses. And then under the square root, we have 2.4 squared over 15 plus 1.7 squared over 12. And when you calculate that, it comes over to negative 2 divided by 0.79046. And then when you calculate that and divide that all together, it approximates to negative 2.53. So since that's in the rejection region, the shaded part, that means we are going to have to reject the null hypothesis. So we can come up with the conclusion that there is a major significant difference at a 5% significance level. So the performance of these teachers are not the same, and there's a significant difference between their performances. So that's our conclusion for this problem. Now we're going to move to the next problem. So let's read this problem together. A business owner is in the process of deciding whether or not to invest in a new factory that refines oil in order to meet the high demand for that commodity. A test showed that the old factory refines oil at a mean rate of 3.1 liters per second, at a standard deviation of 1, using a sample size of 40. The new factory was measured to refine oil at a mean rate of 3.8 liters per second at a standard deviation of 1.5 using a sample size of 36. Determine if there is any major difference at a 10% significance level. So we're going to start out writing the old versus the new, just like we did in the other problem, but fill in the new numbers. So first, we're going to start with the old. So right now, we're just writing information that we already can get from the problem. So the sample size, N1 equals 40. In the sample mean, the rate that oil is refined, so that's going to be the 3.1 liters, but we're just going to write the 3.1. And then the sampled standard deviation equals 1. Now we're going to write for the new, N2 equals 36. The sample mean of 2 is the rate of 3.8 liters per second, and then S2 equals 1.5. Now our next step is to write the null hypothesis and the alternative hypothesis. So we're going to start writing that down here. So a test is being conducted to see if there's any major difference, which means that the alternative hypothesis is that these two are different. If you don't believe that they're not different, you wouldn't really conduct this test. So the null hypothesis, sorry, we're going to write them up here instead. So we want to test to see if they are different. So I'm going to write that. Mu1 does not equal mu2. So remember, another way that we could write this is mu1 minus mu2 equals 0. And then mu1 minus mu2 does not equal 0. for the alternative hypothesis. Our next step is to determine if we have a t-distribution or a normal distribution. We need to look at the sample sizes to determine which method to use. So both of the samples are large. Both are greater than 30. So that indicates we could use the z-test for the normal distribution. So we're going to draw a picture really quick. Sorry, that's not great. Just like before, we're going to do the reject regions shaded. And we need to determine the critical z values that separates the rejection region from the fail to reject region. In order to do that, we need to determine the area involved. So alpha in this problem is 0.10, which means that we have a 90% confidence level. So we write that as 0.90. So the area that's not shaded is 0.90, and then what's not is 0.05. Cumulative area to the left is 0.95, so we're going to write that as A. So I have the positive z-squared table pulled up. I'll insert a picture of it here. So we need to find the area value of 0.95 because that's what this over. So this is 1.645, negative 1.645. So now that we have those, we need to find the calculated z values. And the formula we're going to use is x bar 1 minus x bar 2 minus the difference of the two means, so mu1 minus mu2 over the square root of s1 squared over n1 plus s2 squared over n2. So now we're going to take this and plug in our values again. So then when you calculate the top and the bottom, the numerator comes out to negative 0.7. The denominator is 0.2958. Sorry, that's supposed to be a point, not a comma. That looks a little confusing. And when you calculate that all together, it comes out to negative 2.366, which ends up being in this rejection region, which means we must reject the null hypothesis. The null hypothesis in favor of the alternative hypothesis. So there is a major difference between the two factories at a 10% significance level or at a 90% confidence level. So this new factory is definitely a lot better than the old one. There's a big difference between the two of them. But to conclude my video, that's how to do a hypothesis test for the difference between two means. Thank you.